Hi guys. Okay, so today's lesson is linear inequalities. This is going to be a 2-day lesson. So we're just going to cover kind of half of it right now. So linear inequalities. The next part of this video, you don't need to write down. I really just want you to listen and absorb. Okay. So before we talk about linear inequalities, which we've done before in my class, with the little less than, greater than, that's what an inequality is, we really need to understand what a graph of a linear equation is, okay? So in my class the last month, we've been graphing these lines, whether it's in slope-intercept form, standard form, or point slope, we know how to graph a linear equation. But what I really want us to understand is that this line has an infinite amount of points that make up the line. Okay, we can see these points that I've graphed right here, right? But there's actually a billion points in between those points that make up that line. All of these points are solutions to this equation. They are answers of X and Y. So it's telling you that all of these ordered pairs are solutions to this function, to this equation. So let me give you some examples of that. So if I were to take this point right here, this is 4, 5. Say that's a solution to the equation because it falls on the line. I could say that this point right here, 0, -3, that's a solution. This point right here, -1, -5, that's a solution. And I'm going to prove it to you algebraically. So we're going to start with 4, 5. Down here, what I did is I wrote down the equation that we graphed, y = 2x - 3, and I plugged in the y value of 5. I plugged it in for y. I took the x value 4 and I plugged it in right there. And then I did some math. 2 times 4 is 8. 8 - 3 is 5. And what you get is this statement, 5 is equal to 5. That's a true statement, which means this ordered pair is a solution to the equation, okay? And I did that with the other points as well, just so you could double check my math here. So any point along this blue line, even if it was like in between and kind of an ugly one with decimals or fractions, if you were to plug it in, it would still come out to be a balanced equation down here. What would happen if we plugged in a point not on the line is that when you plugged it in, it wouldn't be balanced at the bottom. It might say like 6 = -2, and you would be like, no, it doesn't. So what I want us to know is that a line, a graphed linear equation, really shows you all the solutions to that function, to that equation, okay? Because today we're going to be talking about linear inequalities. So once again, I just want you to watch this. I want you to listen before we write stuff in our spirals. So I took that same setup, and it is in slope-intercept form, but instead of having an equal sign right here, I'm going to put in an inequality sign. So I'm going to put in a less than symbol. So this is y is less than 2x - 3. So to see all the possible solutions to this inequality, we would have to graph it. So I would start by graphing at my y-intercept, which is 0, -3. So I go to -3 on the y-intercept. Slope tells me where my next points go. So that has a slope of 2, which is the same as 2/1. So up to right 1, up to right 1, up to right 1. I can also go down to left 1 because that's equivalent. I take my ruler, and then this is where eventually you'll learn to stop and freeze and pause. There's going to be a difference between a solid line and a dashed line. Okay, so I'm going to hold off on connecting those dots. And here's what I want us to do. We're going to take this point right here. This is 4, 5. And I'm going to plug it in to this equation, or excuse me, not equation, plug it into this inequality. So I'm going to replace y with my y value, which is 5. It's less than 2 times my x, which is 4, minus 3. So I'm taking this inequality and I'm plugging in the 5 for the y value and the 4 for the x value. And I want to see if this comes out as a true statement. If it comes out true, it's a solution. If it doesn't come out true, it's not a solution. So here we go. 2 times 4 is 8. 8 minus 3 is 5. And I get this statement, 5 is less than 5. Is that true? Is 5 less than 5? No. So what that means is 4 comma 5 is actually not a solution. Let's try another one. Let's do 1, negative 1. So I'm going to plug in negative 1 for the y value, plug in positive 1 for the x. 2 times 1 is 2. 2 minus 3 is negative 1. And I get this statement, negative 1 is less than negative 1. No, it's not. That's not a solution either. It falls on this line of the inequality, but these points along this line are actually not solutions. What they do is they show you a boundary line of all the possible solutions to this, okay? What's going to happen, an inequality, if you just think about basic inequalities like x is less than 5, there's a bajillion numbers that x could be. X could be 4, x could be 2, x could be negative 10, could be negative 1. There's a bunch of numbers. And if you remember on a graph, on a number line, we would put an open circle at 5 because it's not equal to 5. It's strictly less than 5. And we would go like this. We would say anything to the left of 5 is a possible solution. Inequalities have lots of solutions. So what we're going to do is, I'm not going to plug in any more dots on the line. But let's try something over in this area. Okay, let's try this one. This would be 4, negative 3. So that's what I'm going to test. Let's see if this comes out to be a solution. Okay, so we would put negative 3 in for y. 2 times 4 minus 3. 2 times 4 is 8. 8 minus 3 is 5. Is negative 3 less than 5? Yes. So that point right there is a solution, okay? Let's plug in another point. Let's plug in this, 4 comma 2. If I plug that in, that would look like 2 is less than 2 times 4 minus 3. 2 is less than 8 minus 3. 2 is less than 5. Yes, that is true. So that is a good solution. Okay, let's plug in one over here on this side of the line. Let's plug in this. This is negative 2 comma 1. Let's see what happens there. So that would be 1 is less than 2 times negative 2 minus 3. 2 times negative 2 is negative 4. Negative 4 minus 3 is negative 7. Is 1 less than negative 7? No. So here's what's going to happen, guys. Notice that you had 2 good solutions on this side of the line, but something over here was not a solution. This line that we almost graphed there, and we're going to connect in a second, it's a boundary line. So these points aren't actually solutions, but they're like your boundary line. And then what they say is anything lower than this is a solution. Now, how would I know which way without plugging in points? You would just look right here. This is a less than symbol. So you would actually end up shading less than the line, lower than the line. Now, since these points are not solutions, instead of drawing a solid line, we would actually do a dashed line. So that indicates that those points on the line are not solutions, but they're a boundary line. And then you would literally shade just like this. You would shade anything lower than that line. Okay. anything in this blue area and beyond, you got to imagine that it goes out. Anything in that blue area is a possible solution, meaning if you plug the point in, it would come out as a true statement. Okay, so that's kind of some background, and feel free to like replay that so you really understand that. But now let's go ahead and we're going to write some things in your notes. Okay, here we go. So first thing I want you to put down is how to solve linear inequalities. The only way to solve a linear inequality is to graph it. Okay, in order to see all the possible solutions, you have to graph it. So we're going to say must graph to see all possible solutions. Okay, must graph in order to see all possible solutions. And let's draw just a quick little sketch. It's not going to be detailed. You don't need to do your tick marks. But what I want you to do is set up your XY and then do like a dashed line looking something like that. Go ahead and shade on one side of the line. Okay, this is just a quick sketch. Because in your notes, I want you to tell yourself that the shaded area contains all possible solutions. Okay, and solutions are answers. So the shaded area would contain all the possible answers. That's what the shading tells us. Okay, so then another little section in your notes, I want you to write how to graph linear inequalities. So graphing, you graph it similar to slope-intercept form. Start with the y-intercept and then use the slope to make new points. So we'll tell ourselves that. Say similar to graphing, and then I'm just going to write y equals mx plus b. So plot point at y-intercept. Okay, which would be your b value. And then after you plot the point, you look at the slope, and that's going to tell you the rise and run. So slope, use slope to find more points. Use slope to find other points. That's your rise and run. Okay. Okay, so you start by graphing it the same, but then if you remember, I didn't connect the dots right away. Okay, so there is a difference between a dashed line and a solid line. There's a difference of when you shade below the line and when you shade above. So that is what I really, really, really want you to do well in your notes, is this next piece right here. So we're gonna say, right here, solid or dash. And then over here, we're going to say shade above or below. Okay. Okay. So solid or dashed line. Here's how you know which is which. So I'd like you to draw a less than symbol, and then you're going to write the word or, and then you're going to draw a greater than symbol. So this means strictly less and strictly greater, meaning it can't be equal. So when it can't be equal, it's going to be a dashed line. Okay, so what I want you to do is around that, you're going to put a box around it, but you're going to actually put a dash box around it. Get it? Okay. So if it doesn't have the little or equal to, it's got to be a dash line because it means that it's not equal to. Okay. All right. Underneath that, let's do the symbols less than or equal to or greater than or equal to. Because those say it can be equal to the line, okay, it can be equal to all those points that make up the line, then that's going to be a solid line. And go ahead and box that with a solid line. Okay. Okay, and then let's talk about whether you shade above or shade below. So if you have a less than symbol, and remember my trick with less than is it makes the letter L, but it's just tilted. So if you have this less than symbol, or you have less than or equal, so if you have any less than symbol, that's going to be shaded below. Because it's less than, you shade downwards. Okay. Just gonna do a squiggly box around there. Alrighty, and then the last one would be shading, knowing when to shade above. So if you have a greater than, so greater than looks like this, or greater than or equal. If it's greater, then it means needs to go up. You would shade upwards. You can say above or up, whatever makes more sense to you. Okay, that's kind of like your rule book right there. Hopefully it kind of makes some sense why it's above and below. Less than, you go lower, greater than, you go higher, right? Hopefully that makes some sense. Okay. Okay. A few more things I want to do in here. This part is going to be called line and shading. Line and shading. So do a couple of these. Here's number one. Go ahead and copy this down. Y is greater than or equal to negative 3x plus 10. Here's what I need you to know. I need you to be able to look at this symbol right here and know whether it's going to be solid or dashed, and know whether you would shade above or below. Okay, so this is a greater than symbol, greater than or equal to. The little equal to underneath tells me that it's going to be a solid line. So I'm going to write that. It's a solid line. That's because it has the or equal to. And then since this is a greater than symbol, I would shade above because it's greater. So you shade higher. So shade above. So you have to be able to know those two things. Okay. So I'll do one more with you. Let's do y is less than negative half x minus 2. Once again, doesn't matter what these numbers are. You're really just focused on the symbol here. This is a less than symbol. Notice it can't be equal. Therefore, it's a dashed line. Okay. Would you shade above or shade below? Well, since it's a less than symbol, you would shade below. Okay. Number 3, you'll enter it in as your entry test question. Here it is. Y is less than or equal to 4x plus 1. So you'll enter in your little 4 words that you put into your entry task. Okay. And then we're going to do just kind of one big graph down here because I didn't want you to graph a million times. So we're going to go ahead and graph y is greater than -3/2 x plus 1. And then, so it says graph that and identify possible solutions. Okay, so we're going to graph y is greater than -3/2 x plus 1 and identify some possible solutions. Okay, so what I want you to do is take some time to set up a nice, beautiful graph. Put your tick marks in, label your x and y axis, and feel free to pause the video if you need additional time. That's what's great about video lessons. You can pause and replay. Okay, so to graph this, we kind of just think of it as an equation almost at first. You start by plotting a point at your y-intercept, which is at +1 on the y-axis, so 0, 1. You look at the slope to tell you additional points. So because it's negative, I'm going to go down and to the right. So I'm going to go down 3, 1, 2, 3, and then right 2. Down 3, 1, 2, 3, and right 2. Okay, now I also like to extend this upwards, and I hope you do too. So instead of going down 3, right 2, you can go the reverse of that. You can go up 3, left 2. Up 3, left 2. It's not perfectly perfect, but okay. And then here's where you gotta really tell yourself two things. What I like to have my kids do and what I kind of do sometimes. I look at that symbol, and that symbol tells me two things. First of all, should it be solid or dashed? Is the line going to be solid or dashed? Well, because it's not equal, it's got to be dashed. And that symbol says greater than. So I'm going to shade above the line because it's greater. Okay. So here we go. I'm going to take my ruler, but I'm going to remember it's not a solid line. So I just put some dashes in between these points. Okay. So that's essentially my boundary line. And all the solutions are going to be above this line. Some kids have a hard time knowing what's above. I just think about if this line were to fall right now, which direction would it fall in? It would fall this way. So that's down, that's below, which means this way is above. So you would literally just shade this direction. Okay, so anything over there is a possible solution. And in fact, it wanted us to identify some possible solutions. So here we go. Possible solutions. Let's go right here. Boom. 3, 2. That's a possible solution. Right here. 5, 0. Okay, and then for an extra entry task question, I want you to tell me another possible solution in this shaded area. Okay, so we will practice graphing more in Zoom, I pinky promise. Okay, that's what we're going to be doing in Zoom, is just graphing over and over so that you get the hang of it. Alrighty, so there you go. I'll see you in Zoom. Bye. Okay, I was gonna go ahead and just graph a few of these with you guys. So here we go. Y is greater than -5/3 x minus 4. So we start by plotting a point at the y-intercept, which is -4. And then this says we go down 5 and right 3. Okay, and then this is where it'll pop up with two choices, change line and change shade. So if you click the change line, it goes from solid to dashed. So in this one, there's no or equal to line. So we would need to make sure that we change it to a dashed line. And then change shade is gonna switch sides of the line. So this says Y is greater. So you would need to go upwards, shades towards the top of the graph. Okay, so shade upwards. And then we would go ahead and submit our answer. Okay, and then we'll do one more. Okay, so I start by plotting the y-intercept at positive 2. This is a positive slope, so I'm going to go up 1, right 3. And then this has a line underneath it, so solid or dashed. Solid line. And then this says y is less than, so I would need to shade below. So I have a solid line, shaded below, submit. There you go. That's how Delta Math works. Good luck.